Hi everyone. In this video, we'll talk about the concept of test statistics and p-value. Test statistics and p-value. Okay. So let's first ask the question, when we do our hypothesis testing, how do we link our sample with our decision? So how to link our sample with our decision. Okay, so that's the question we want to answer in this video. And this involves the concept we learned before, is the concept of standardization. Standardization. Okay, it's the concept of standardization. Let's say you're given some values, some population values, and then you're asked to do a testing. Okay, so this is a normal distribution, and let's assume that you're given mu h naught, right? So this is the value that I want to test using a sample, whether this is true. Okay, so it's the mean under the null hypothesis, and then you're also given your standard deviation. Your standard deviation, right, talks about how to spread out your data, and you are given the alpha, the significance level, right? So you're given how much mistake or the probability of rejecting the null when the null is true, the alpha you allow yourself to make, right? The mistake you allow yourself to make. Let's say in this case, alpha equals to 5%. Okay. So critical value and critical value, these two rejection regions, they add up to 5%. Now the question becomes, what are these two critical values? So what are the critical values that it will give you 5% rejection regions, right? So this is a really hard question because every single set of mu standard deviation, they're different. There's so many combinations, and you cannot remember, or just not possible to have all the critical values ready for you to check compared to your sample with when you're given a question, right? So what are the critical values, right? It's just hard to answer because we have each normal distribution is different. Okay, so each single normal distribution is different. It's just really hard to come up with this critical value at the spot, right, when you are given a set of normal. But the good news is we can make standardization, right? So with the standardization, with our z-scores that we discussed before, the standardized normal, we can easily to use our z-table, right? So standardization is really helpful here. And just quick review, a standard normal is a normal distribution with zero mean and standard deviation or variance to be 1. So this one is the mean 0, and the variance is 1, right? And of course the standard deviation is also 1 in this case. Okay, so we need to do standardization. Okay, let me just go ahead and give you the name of this process. This is our test statistics. It's the value that you're going to use it to compare with your critical value. This equals to your sample mean minus mu h naught is the value under the null hypothesis divided by your standard error, which is the standard deviation of your sample mean here. Okay, so this is the process of standardization. One thing I want to point out is here we are looking at the distance between your sample mean and the mean under the null, right? So if these two are close to each other, then this value should close to 0. If they're not, they're very different, then this value is far away from 0, right? Okay. So that's that. Let me do the standard normal curve. Okay. So what's special about the standard normal is 0 is the mean, right? After you do the standardization, 0 is the mean, and then if we're doing a 5%, so if we're doing alpha equals to 5%, then we know that this is 2.5%, and this is 2.5%, then this is very easy for us to find the critical value, because you can just jump into your z table and find the critical value in this case. On the left hand side, it's minus 1.96. The right hand side, it's 1.96, right? Because you're just so easy to just use the z table. Now, with this standardized normal critical value, the test statistics is the sample value that you're going to use to compare with your critical value. If your test statistics is closer to 0 than the critical value, right? That means these two numbers are pretty similar to each other. Then in this case, you're going to fail to reject the null, right? Because your sample mean is very close to the mean you're testing, right? But if it's far away, if it's away than the critical value, then you're going to reject the null. Okay? And the good thing about this is you know the critical value right away. Okay, good. So let me conclude what is the method for testing. So this gives us testing method 1. Okay. So testing method 1. If the absolute value of your test, let me write test statistics, right? If the absolute value of test statistics is greater than the absolute value of critical value, then you're going to reject the null hypothesis, right? Why we have to do the absolute value is because if you look at this side here, right? So if you don't look at it with the absolute value, if your test statistics is here, the value itself is less than negative 1.96. So if you want to do the comparison and make sure that this is outside the critical value, then you have to look at it in the absolute value, okay? And the opposite, if your test statistics is less than your critical value, then you're going to fail to reject your no, okay? So if your test statistics is inside your critical values, stay here, then you're going to fail to reject your null hypothesis. So this is the concept of test statistics and how you would use test statistics to make your decision, whether you reject your null or fail to reject your null. Okay. Now I want to talk about the concept of p-values and how you would use p-values to do testing. P-values. So let me first give you the formal definition. Okay, so formal definition is the proportion of data which falls beyond your test statistics. Okay. So what are the proportion of data that's outside your test statistics? If you look at from this normal distribution, and you see, say 0 is in the middle, right? So everything is standardized. Your test statistics, I'll just say t-stats. Save some space. T-stats. Okay, so oops, let me do it here. Right, t-stats. So p-value are the areas outside your test statistics. So these two areas, they add up to your p-value. Okay, so this looks similar when we do it with the critical value, but the critical value, if you have two critical values here, these two are rejection regions and they sum up to your alpha, your significance level. But when you have your t-statistics, all the area outside this region are sum up to your p-value. Okay. And that's the formal definition. Let me give you a different interpretation of the p-value. Okay, so another interpretation would be, given the null is true, given the null is true, the probability of rejecting the null with the data given. Okay, so based on your data, what is the probability that you will reject your null when the null is true? Okay, so this sounded similar to our alpha significance level, but in fact they're different. So take a note. Alpha is the probability you allow yourself to make the mistake, right? And the mistake is, and the mistake is when the null is true, you reject the null. Okay. So this one is the probability you will make the mistake of rejecting a true null given your data, and alpha is the probability you allow yourself to make the mistake, right? So this is you will make a mistake, and this is allow yourself to make a mistake. Okay. And then before we go into how you can use this concept to do decisions, I want to quickly point out is that to get your p-value from a z table, it's the same as how you would use a critical value to find your no. So finding a p-value, you would do the opposite, right? So once you obtain your t statistics, then you go back to your z table and find the area here, right? If it's one-sided, then you find the area here or here. But if you're doing two-sided tests, then you will just double the area here with your z table. And that's how you will find your p-value from your z table, which is using the test statistics you get from your data, okay? Now, let's continue with this here. And I'll do an example to show you how you would do this. Okay? So this will give us testing method 2, right? Testing method 2, it's if the p-value you get is greater than alpha, then in this case, you'll be more likely to make the mistake than you allow yourself to make. Right? This is easy to make mistake. Right? So then you're not going to do it, right? So because you're more likely to make a mistake, then you're not going to do it. So this case is fail to reject the null hypothesis. Okay? And opposite, if the p-value is less than alpha, that means you're less likely to make a mistake than you allow yourself to make. Then you're going to just go ahead and not make a mistake, but you're free to reject the null hypothesis because you're less likely to make a mistake with the data on hand. Okay? And these two are the two approaches or two methods you're going to use to do your testing. Now let's do an example and to show you how you apply these concepts here. So the example is our reading, it's by reading class again. So we're reading, speed, the national mean. So mu equals to 300. So that's the national reading speed average. And then the population standard deviation, it's sigma equals to 40. And then in your reading class, you have 10 sample. So you take sample from reading class. And the sample mean you get, the sample mean for the X bar equals to 308, right? And now the question you want to ask is whether this class improves your reading speed, can help you increase your reading speed. Okay. So our null hypothesis, let's say it's not. So you're looking at the population, then for people, mu is less or equals to 300. And then alternative is mu greater than 300. Okay. So you need to be greater than 300 to be helpful, right? You need to be above the national mean to be helpful. And before we move on to the next step, let's pick a significance level. So let's pick our significance level alpha equals to 0.01. Okay, 0.01. And if you look at the normal distribution here, you have 300 in the middle, right? So it's always the distribution under the null when the null is true. And we're looking at the right hand side because we want to show if it's improved your reading speed. So this is 1% here, right? We're doing a one-sided test, and then alpha is 0.01. Okay, just so you know, we're doing a one-sided test. Okay, good. Well, let's find the critical value. So let me name this one 1. So we want to pick the alpha first, and then 2 is we want to find critical value. Okay, so find critical value, we can just go ahead and assume that since later we'll do the test statistics, then we can just look at it from the standardized normals perspective. So once it's standardized, with our Z table, the right hand side 1%, the critical value we get from the Z table is 2.326 from Z table. Okay. Now, the third step is to find your test statistics. Okay. 3, your test statistics, in this case, equals to x bar minus mu h0 divided by standard error. And remember the standard error, the formula is population standard deviation divided by square root of sample size. That's going to give 308 minus 300 divided by 40 divided by square root of 100. And after some calculation, this will give us 2. So 2 is our test statistics. Okay, and the fourth step, we can just go ahead and make our decision. 4, we're going to compare this critical value and that test statistics. So because the square root of 2 is less than the square root of 2.326, which is our test statistics, in our value is less than our critical value, we're going to fail to reject the null hypothesis. Fail to reject our null hypothesis. Okay? So if a question asks you to do hypothesis testing and doesn't ask you to calculate the p-value, you're done, right? You're done using method 1. But for the purpose of this video, let's do one more step. Calculate the p-value and then use the p-value to make our decision. Okay. 5 is to calculate our p-value. Okay, so the way we get our p-value is we have our test statistics, right? So we have our test statistic to be 2. So when we find the critical value, we know the area here is 1%, and we find the critical value here using our Z table. But what we're doing now to find the p-value is the opposite, because we know the test statistics, and we can use the Z table to find area here. Okay, and when you use your Z table, this is 0.0228, okay, or 2.28%. Okay, that's area. Okay, 6 is make our decision, and this time we're gonna use our p-value to compare with alpha. So our p-value equals to 2.28%, and our alpha was given by ourselves is 1%, and since our p-value is greater than our alpha, that means we're likely to make a mistake, then we allow ourselves to make, then we're not going to reject the null. Fail to reject null hypothesis, okay? So when we fail to reject our null hypothesis, then what's the conclusion? Conclusion from using the test statistics and our p-value, the conclusion is reading class might not be helpful. So we're going to conclude Mike's reading class might not be helpful. Okay? Okay, and that's our conclusion here. Very good. So in this video, we talked about the concept of test statistics and p-value and how you would make your decision based on test statistics and p-value. Thank you for watching. I'll see you in the next video.